Let's move on towards lecture number 30 of matrices. So in this 30th lecture of matrices, 29 lectures are already over. I have already told you to go to the channel page and have a look at the previous 29 lectures. Okay, only then you will be able to understand this particular lecture. So let's move on towards lecture number 30. Property number 8. If A is any square matrix, suppose capital A matrix is any square matrix, then what do we have? What the property says? The property says that A minus A transpose will be skew symmetric matrix. A minus A transpose will be skew symmetric matrix if A is any square matrix. Okay. And why do we need a square matrix? Only then transpose and matrix can be added or subtracted. Only if A will be square. If A is not a square matrix, then A minus A transpose will not be defined. A minus A transpose will not be defined if A is not square. So, if A is a square matrix, then A minus A transpose is skew-symmetric matrix. Let us prove this particular fact. So, A minus A transpose complete transpose. Let us take its complete transpose. Okay, so after taking its complete transpose, the property says, what does the property say? Property says that A minus B transpose, A minus B complete transpose is equal to A transpose minus B transpose. This is the property which we already know. This is a property which we have already learned in the previous lectures. So A minus A transpose will go over here. So A transpose and transpose will also go over here. So minus A transpose from this particular property. Okay. Now A transpose remains as it is and the minus sign remains as it is. A transpose. When we take transpose of transpose, we get the original matrix. Okay, when we take a matrix's transpose, and once again we take its transpose, then we get the original matrix itself. So the expression came out to be A transpose minus A. A transpose minus A is the expression which we got. Now let us take out minus sign common from this. Let us take out minus sign common out of this expression. So as soon as you take minus sign common out of this, A will become plus, from minus it will become plus, and this from plus it will become minus. So minus of A minus A transpose. Minus of A minus A transpose. Now if you consider that this A minus A transpose is a matrix C, and if we consider like that, then what is this? This is C. This is C, right? This is C. Just a second, guys. What happened? I don't know. This is C, right? So C transpose is coming out to be equal to minus C. You can have a look. This complete expression is C. So C transpose is coming out to be equal to minus C. So C transpose is equal to minus C. That implies C is skew symmetric. That implies what? That implies C is skew symmetric. But C is equal to what? C is equal to A minus A transpose. So A minus A transpose is skew symmetric matrix by definition. By definition of skew symmetric matrix, if we look at this expression equal to this expression, then from the definition of skew symmetric matrices, okay, from definition we can say that A minus A transpose is skew symmetric matrix. Okay, A minus A transpose is skew symmetric matrix. In this way we have successfully learned this particular property.